Standard 10th Maths Chapter 2 Creative Questions for Centum Scorers Part 4. See, we are going to discuss the questions from the second chapter. First sum, example sum 239, page 66. So just let me do the sums for you. See, the problem is the sum of first n, 2n and 3n terms of an APR S1, S2 and S3 respectively. Prove that S3 is equal to 3 into S2 minus S1. First, the sum of n terms in an AP is given as in an AP. Sum of n terms. Sum of n terms is given by the formula Sn equal to n by 2 2a plus n minus 1 into d. This is the formula given for you. So now take the given concepts. The sum of first n, 2n and 3n terms of an APR S1. So S1 is sum of n terms. S1 is, so as it is the given in the formula here, n terms, sum of n terms. So that is S1, our S1. So n by 2, 2a plus n minus 1 into d. And S2 is sum of 2n terms. So S2 is equal to sum of 2n terms. Replace n as 2n. 2n by 2, 2a plus 2n minus 1 into d. Then S3, sum of 3n terms. S3 is equal to sum of 3n terms. 3n by 2, 2a plus 3n minus 1 into d. So just, this is our original formula. You replace that S1 as same formula n terms. But S2 is sum of 2n terms. Replace n as 2n. Just replace n as 2n. Then S3 is sum of 3n terms. Replace n as 3n. So now we are going to prove this. S3 is equal to, prove that S3 is equal to 3 into S2 minus S1. First let me take the right side terms. Right hand side. Bracket term first. S2 minus S1. So what is S2? 2n by 2, 2a plus 2n minus 1 into d minus S1 is n by 2, 2a plus n minus 1 into d. So here first let us collect the common terms here. Here 2n by 2. Here n by 2. So let me take n by 2 as common here, n by 2. So if I take n by 2 common here, 2 is left here, numerator 2 is left here, just you multiply this, 2 2s are 4, 4a plus 2 into, you have to multiply this term also, 2 into 2n minus 1 into d. Put minus, already this n by 2 is outside, so just you will get minus 2a minus n minus 1 into d. So n by 2, 4a minus 2a is 2a plus, so this you multiply, 2 2s are 4n into d, 4nd minus this minus 1 2s are 2d, 2d. Already I subtracted here this a. Now take this minus nd. minus nd. Minus into minus plus 1 into d, 1d. n by 2, 2a. See 4nd here minus 1nd, so you will get 3nd minus 2d plus d, so minus d. So here n by 2, 2a plus, take d as common, so you will get 3n minus 1, 3n minus 1. See, actually right side term is 3 times 3 into. So 3 into S2 minus S1. So multiply the term by 3. So 3 into n, 3n by 2. That's all. Write the bracket term 2a plus, you first write 3n minus 1 into, then write d. Okay. So this is the formula for S3. See, S3 is sum of 3n terms. Same formula here you have got. So this is equal to S3. S3. So this is our right hand side. That's all. See the next sum. This is not given in your book. See, it's outside of the textbook sum. The sums of n terms of 3 arithmetical progressions are S1, S2 and S3. The first term of each is unity and the common differences are 1, 2 and 3 respectively. Prove that S1 plus S3 is equal to 2S2. See, S1 is the first term of each is unity. For S1, S2, S3, for all the summation, the first term A is unity. But the common difference is different. For S1, common difference 1. For S2, common difference 2. And for S3, common difference is 3. We have to prove this statement. First, let me write the general formula. Sn equal to, actually n by 2, 2a plus n minus 1 into d. Okay. See, what is S1 they given? S1 is first term, sum of n terms whose first term that is A. A is 1 and common difference D is also 1. So how do you get S1 from Sn? So just keep n term, sum of n term, but substitute A as 1, 2 into 1 plus n minus 1 into D. D is 1. So you will get S1 as n by 2, 2 ones are 2 plus 1 into n minus 1. So what you will get? N by 2, 2 minus 1 is 1 plus 1. You keep this one and write S2. What is S2? Sum of n terms. Sum of n terms, but whose first term A is 1, but D is 2. So write S2. Keep n as same. N by 2, 2a, 2 into 1, n minus 1 into D. D you have to replace as 2. So n by 2, 2 ones are 2, 2 into n, 2n minus 2. So you will get here 2, 2 cancel. So n by 2 bracket 2n. See again these 2 and 2 cancel. N into n is n squared. Now come to S3. S3 is sum of n terms. But whose first term is also, whose first term A is 1, but D is 3. Substitute here in the formula. S3 is n by 2, 2 into 1 plus n minus 1 into D is 3. So n by 2, 2 into 1, 2, plus 3 into n, 3n minus 3. So n by 2, 3n, 2 minus 3 is minus 1. Okay. See, what you are supposed to prove, the statement here is, the statement is S1 plus S3 is equal to 2S2. Prove that S1 plus S3 is equal to 2S2. Take S1 plus S3. S1 plus S3. See, S1 is here n by 2 into n plus 1. N by 2 into n plus 1 plus S3 n by 2, 3n minus 1. Take n by 2 as common, n plus 1 plus 3n minus 1. See, if you take n by 2 as common outside, here the remaining one is n plus 1, sign plus 3n minus 1. So n by 2 plus 1 minus 1 cancel. So you will get 4n. 2 into here it goes 2 times. So you are getting 2n squared. 2n squared. But you are supposed to prove 2s2. So what is s2? N squared. So 2 times s2. 2 times s2. So this is our right hand side answer. That's all. See, next sum. If the sum of m terms of an AP is the same as the sum of its n terms, show that the sum of its m plus n terms is 0. See, in an AP, the sum of m terms is equal to, is same as the sum of n terms given. This is given to show sum of m plus n terms, Sm plus n, is equal to 0. You have to show this one, S of m plus n is equal to 0. Actually, in AP, you write the formula sum of n terms, n by 2, 2a plus n minus 1 into d. What is given? Sum of m terms is equal to sum of n terms. So sum of m terms is m by 2, 2a plus m minus 1 into d, n by 2, 2a plus n minus 1 into d. See, let us simplify this. First, you cancel this 2 and 2 in the denominator. You have to multiply these two terms by m. So 2am plus m into m minus 1 into d is equal to 2an plus n into n minus 1 into d. So remove the brackets here. 2am plus m into m squared d, 1 into m minus md. So bring it to the left side here. First you simplify the right side. 2an plus n into n squared into d minus 1 into n d. So bring all to the left side. M square d minus md minus 2an minus n square d plus nd is equal to 0. Now you group the terms 2a, 2a. So 2a is common here. You will get m minus n. And then here 1 d here d. See, plus m squared minus n squared d. This one and this one. And here md and plus nd. So I take one minus outside. So this m becomes plus, but n becomes minus. D is equal to 0. See, 2a m minus n plus m squared minus n squared is here. M plus n, m minus n into d minus m minus n into d is equal to 0. See, 3 terms are here. 1, 2, 3. In all the term we have m minus n common. So take it outside. Inside the bracket you will get 2a plus m plus 1 n into d, and m minus n we have taken outside, so just d alone here left here, 0. So m minus n 2a plus, see here 1d, here 1d. For these two terms d is common. So let me take d outside. So you will get inside the bracket m plus n. Then the coefficient of d is here 1 minus 1. D is equal to 0. See, m minus n into 2a plus m plus n minus 1 into d equal to 0. So either this equal to 0 or this equal to 0. Either m minus n equal to 0 or 2a plus m plus n minus 1 into d is equal to 0. See, but this m minus n cannot be equal to 0, isn't it? So m minus n cannot be equal to 0. Therefore, 2a plus m plus n minus 1 into d is equal to 0. So you keep this as it is. So I am going to show that Sm plus n equal to Sm plus n equal to 0. So write the Sm plus n. Sm plus n. Sn n by 2. So m plus n by 2. 2a plus, you replace n as m plus n. 2a plus n minus 1, that is m plus n minus 1 into d. See, the bracket term 2a plus m plus n minus 1 into d. The previous step we have got this as 0. Therefore, m plus n into 0. This is equal to 0. Just you mark this as 1 and write from 1. From 1. So this is the proof. Sm plus n is equal to 0. This is the answer. See, all these two sums are given outside the textbook, but easy one. You can practice that when you are free. Now let me give you the important sum from our textbooks. All these are same, just they are different sums. They may ask you in the creative questions. See, all these are 5 marks question, important question. From exercise 2.6, sum 11 and sum 12. Exercise 2.7, sum 12. Exercise 2.8, sum number 10. Exercise 2.9, sum number 7. And example sum 252, page number 75 from your textbook. So all these sums I work out and give you as a video, so you can refer that. So practice well, students. Thank you.